Hi everyone, welcome to Mr. B's Learning Channel. In this video, we are going to discuss how to sketch a cubic function. Standard form of a cubic function is f of x is equal to ax cube plus bx square plus cx plus d. And the shape of a cubic graph. Looking at a, the symbol of a, if a is positive, that is greater than 0, the graph will look like this. That is starting a concave down, then a concave up. This is how the graph will look. And another shape is, if looking at a, that is a is negative, that is less than 0. The graph starting with a concave up first, then a concave down. You see that? This is how the graph. These are the general shape of a cubic graph. There is a special case also there. We will discuss that one in one of the coming videos. Now we move to the turning point of this graph. That is turning point. Like parabola, cubic graph also got turning point. Under normal situation, it has two turning points. You can see that one is here, another one is here. How do we find the turning point of cubic graph? That we discussed in one of the previous videos. We know that at turning point, if you draw a tangent, that tangent is a horizontal line. You know that one. So the gradient of a tangent is going to be 0 at turning point. Okay, the first turning point, in this case, this turning point is the local maximum turning point. Local maximum. And this point is local minimum. Similarly, when it comes to this graph, concave up and concave down, the first one is a local minimum, then local maximum. Is bottom one, then this one is the top one. You see that one? There also we can see what tangent is horizontal, which means the gradient of a tangent is 0, which is equal to gradient of a curve at that point. Gradient of a curve, how do we get it? Differentiate the function dy by dx is equal to 0, gradient of a tangent. So we are using this formula to find the x value of the turning point. Differentiate and equate to 0. Then solve for x. After finding x, substitute in the main function, that is substitute in f of x. Main function means equation of the cubic graph, because turning point is a point on cubic graph. So after finding the x value, substitute in the main function to get the y value of the turning point. Next item about the cubic graph is point of inflection. Point of inflection. How do we find a point of inflection? What do you mean by point of inflection? You know, a cubic graph, see, concave down, then concave up. There is a point somewhere here. This concave down will change to concave up. This point is known as point of inflection. Is it clear? Similarly, this graph, see, concave up, then concave down. There is a point somewhere here. This point is point of inflection. Inflection. How do you find this point? You have to take the main function, then differentiate 2 times. That is d square y by dx square, or f double dash x. Dash x means differentiate once, then double dash means differentiate twice. Then after that you have to equate to 0, then solve for x. You know that a cubic function, when you differentiate, you will get quadratic. Then you have to differentiate it again, you will get a linear expression. Then equate to 0 and solve for x. That is the x value of point of inflection. Then how do you find y value? Substitute in the main function. Main function means again you have to substitute in f of x to find the y value. So that is the point of inflection. It is the point where concave up will change to concave down, or concave down will change to concave up. Next thing in about a cubic graph is increasing and decreasing portion of a cubic graph. Let me draw a cubic graph. See, concave down and concave up. This is a cubic graph. Then when you look at from left to right, see the graph is increasing. We can see that when I put arrows, we can see that arrows are pointing upwards, increasing and reach the turning point. Then what happens? Turning point means their graph is not increasing, not decreasing. That is why its name is stationary point, turning point. Okay. Then what happened? It is decreasing. Do you see that one? It is decreasing and reach the next turning point. That is the local minimum here in this case. Then it is increasing. Is it clear? So this portion, the graph is increasing. So between two turning point, graph is decreasing. Before the turning point, first turning point, graph is increasing. Here also graph is increasing. Now look at this cubic function. See, first before the first turning point, what happened? Graph is decreasing. You can see that it is going down. Then this graph is increasing. Between the turning point, graph is increasing. Then it is started decreasing. Do you see that one? So the portion where graph is increasing means there the gradient of the curve is positive. Okay. Then at turning point, gradient is 0. Then what will happen? Decreasing portion, gradient is negative. So that also must be there in your mind. You have to find the x values where graph is increasing, or find the x values where graph is decreasing. So first you have to find that portion. Then after that, you have to find the x values corresponding to that portion. Is it clear? Okay, now I will show you how to draw this cubic graph. Starting from the beginning, I will show you that one. It is like a parabola. Parabola, when you draw it, we need x-intercept, y-intercept, and a turning point. Similarly, in cubic graph also we need x-intercept, y-intercept, and a turning point. But we are using different methods there. So let me start with the x-intercept. X-intercept. How do you get x-intercept? Put y is equal to 0 in the main function. That is f of x becomes 0. Because you know that y and f of x, they are same. That is 0 is equal to x cube plus 4x square plus x minus 6. Now you have to solve and find x value. How many x values will be there? Because it is an equation with the power 3 means you have to get 3 x values. Out of 3 solution, first one you have to get it using factor theorem. Factor theorem means go to the constant. What is constant here? Minus 6. Take the factors of minus 6 and substitute one by one. Check which one will give 0. So minus 6 factors are plus or minus 1 is there, then plus or minus 2 is there, plus or minus 3 is there, then plus or minus 6. That is the number that can divide minus 6. You have to consider positive and negative. So let me start with 1. It is better, especially a situation like this, start with 1, then minus 1, then 2, then minus 2, then 3. So just substitute until you get 0. So let me start with x is equal to 1. Let me check whether this will give 0. That is, replace x with 1. That is 0 is equal to 1 cube plus 4 times 1 square plus 1 minus 6. That is 0 is equal to, this is going to be 6 minus 6. So 0 is equal to 0. So the first number is giving me 0, which means x is equal to 1 is a solution. So or we got first x-intercept, that is 1. Now how do you get the rest of the x-intercept? How many x-intercepts are left there? 2 more, isn't it? Because altogether 3. Where first one we got it, Now I'm going to look for other two. For that I'm using synthetic method. So I have to draw a big L here. Inside the L you have to write A, B, C, D. 4 numbers must be there. That is here 1, 4, 1, minus 6. You know how to do it because I did one video for this one before. So if you have still problem, go to that video and see it. Then you will get an idea what I am doing now. So outside this L, I have to write that x-intercept that I got it now. That is 1. Now the first step is this number will go down, isn't it? So it's going to be 1 here. Then after that, that number will multiply with this x-intercept and write under the next number. That is 1 times 1 is 1. I'm writing under 4. Then I'm adding. So it's going to be 5. Then I'm doing the same thing. This 5 is going to multiply again this first x-intercept and write it under the next number. That is 5 times 1 is going to be 5. Then I'm adding. That is going to be 6. Then 6 also doing the same. 6 also going to multiply this 1 and write the answer under the next number. That is again 6. Then add it is going to be 0. You have to get 0. If you get 0 means your work so far is correct. So these are the A, B, C, D of cubic and these are the A, B, C of quadratic. You know those two x values, x-intercepts are hiding here. I'm going to take it out, that one. That is, that quadratic equation is 1x square plus 5x plus 6 is equal to 0. This one I can factorize it very easily. That is x plus 3, x plus 2 is equal to 0, isn't it? Because 3 times 2 is 6, 3 plus 2 is 5. So I can factorize it very easily. So I got next to x-intercept, that is x is equal to minus 3 or minus 2. So I have all 3 x-intercept, that is one I got it using factor theorem, then other 2 I got it using synthetic method. It's clear. Now I am going to look at y-intercept. Y-intercept. It's also same as parabola. Y-intercept, how do you get it? Make x 0. So the main equation is y is equal to x cube plus 4x square plus x minus 6. Y-intercept is always the number without x. That is this one. So x is equal to 0. You will get minus 6. Substitute here. You will get minus 6. So that is the y-intercept. Okay, now coming to the turning point of the cubic graph. Let me write the main function. That is y is equal to x cube, then plus 4x square plus x minus 6. This is the equation of the main function. That is f of x. Y, you know that f of x. So how do you find turning point? You have to differentiate and equate to 0. That is the formula that we are using. That is dy by dx is equal to 0. So learners, don't confuse. When it comes to turning point, don't use this formula x is equal to minus b over 2a. Don't use it. This one is only using for finding the x value of the parabola. Okay, here in cubic graph we can use differentiate and equate to 0. Even this differentiate and equate to 0 you can use it in parabola. There is no problem. I think I showed you one of the videos before. So you have to use dy by dx is equal to 0 to find the x value of the turning point. Clear? So let me find dy by dx. So it's going to be 3, because this is our y. I'm going to differentiate. So it's going to be 3x square plus 4 times 2x plus 1 and equate to 0. That is 3x square plus 8x plus 1 is equal to 0. Now you have to solve. This is a quadratic equation. Always when you differentiate a cubic, it's going to be quadratic. Now what you have to do is you have to use a quadratic formula. That is x is equal to, you know the formula, minus b plus or minus square root of b square minus 4ac all divided by 2a. Then substitute, that is x is equal to minus 8 plus or minus square root of 8 square minus 4 times a is 3 times 1 divided by 2 times a is 3. So when you do this one, you will get it x values minus 8 plus or minus square root of 52, you will get it, divided by 6. When you simplify, it's going to be two values you will get it. One is minus 0,13 or minus 2,54. I rounded off 2 decimal places. This is how we get it. These are the x values of the turning point. Now how do you find y value? Substitute each of them in the main function. Clear? So I'm taking the first x value, that is this one, and I'm substituting in the main function. That is y value is equal to minus 0,13 all cube plus 4 times minus 0,13 all square plus minus 0,13 then minus 6. When you do this one, you will get the answer minus 6,06. So we got our first turning point. Then the next turning point when x is equal to this one. Do it the same thing, that is substitute in the main function, that is minus 2,54 all cube plus 4 times minus 2,54 all square plus minus 2,54 minus 6. When you do this one, you will get the answer 0,87. That is the y value. You get it. You understand? So we got two turning points. First turning point is minus 0,13 is the x value. Y value is minus 6,06. Then the next turning point is minus 2,54 is the x value. Then y value is 0,87. So we got two turning points. Now we can draw the graph. Okay, now I'm going to draw the cubic graph. So the information that those are required to draw the graph, I got it because you saw that. How did I get that one? Now I just wrote it here: x-intercept, y-intercept, and turning point. These are the information we need to draw that graph. So let me draw the graph. That is, first let me draw the y-axis, then x-axis. See, I'm drawing approximately, not accurately, approximately. Actually, I'm sketching the graph. Now, first thing that I have to do here is to plot the x-intercept. That is 1 somewhere here. Then here it is minus 2 on the left-hand side of y-axis. That is somewhere here, minus 2, then minus 3. I plot that. Then y-intercept is down here under the x-axis. You know that is somewhere here, minus 6. Now the turning point. What is the first turning point? Minus 0,13. Isn't it? Let's make this positive. Minus 0,13 and minus 6,06. That is, minus 0,13 is a point before minus 1, minus 0, that is somewhere here, close to the x-axis. Then just down of minus 6 is minus 6,06. So it's somewhere here. This is the turning point, okay? Bottom turning point. Then top turning point is minus 2,54. That is minus between minus 2, that is somewhere here. Then 0,87 is somewhere here. So that point is here. That is the top turning point. So the graph, when you draw it, so it's going to go like this. See? So this is how the cubic graph will look. You see that it has two turning points. This turning point is minus 2,54. Then x value, y value is 0,87. Then this turning point is minus 0,13, then minus 6,06. So it is better to indicate the turning point on the cubic graph. It's clear. Now I will show you how to find the point of inflection. See, the main function is here. You have to differentiate twice. I will show you that. First differentiate one time, that is f dash x. Just differentiate once. That's going to be 3x square plus 8x plus 1. Minus 6 is going to be 0. You know that one. This one is the first derivative. When you equate this one and solve for x, that is the x value of the turning point. We don't want that one. We need what? Point of inflection. For that, you have to differentiate this one once again. That is f double dash x. It's going to be 6x plus 8. Then equate to 0 and solve for x. That is 6x is equal to minus 8. That is x is equal to minus 8 divided by 6. So the answer is minus 4 over 3. This is the x value of the point of inflection. Then how do you get to y value? You have to substitute this one in the main function, not in the first derivative or second derivative. You have to substitute this one in the main function, that is f of bracket minus 4 over 3 is equal to minus 4 over 3 whole cube plus 4 times minus 4 over 3 whole square. Okay, then plus minus 4 over 3, then minus 6. When you do this one, you will get minus 2,61. Minus 2,61 you will get it. That is the y value of the point of inflection. So the point of inflection, we can write it. X value is minus 4 over 3. Let me change it into decimal. That is minus 1,33. Then the y value is minus 2,61. Is it clear? This is the point of inflection.